go. Okay. Over 35 years ago, world-renowned English physicist and radio astronomer Sir Alfred Bernard Lowell wrote, "It seems that space expenditure has been extremely reasonable in terms of dividends to human enterprise, scientific knowledge, and actual and potential national economic gains. People who argue that it would be better to spend the money in various other ways do not seem to be aware of these facts. In light of the recent cut of the NASA Constellation program in the 2011 budget, it seems this is still the case. Today I will be arguing that space exploration has a positive impact on the economy. Space exploration programs are not money sinks. Space exploration as a fiscal policy already creates profits far beyond its own costs. Award-winning mathematics and science professor Stephen Cook of the University of Toronto says, on average, each dollar spent on the U.S. research and development in the space program returns about $9 in technology-induced economic gain. G. Scott Hubbard, professor of aeronautics and astronomics at Stanford University and former director of the NASA Ames Research Center, backs up this claim. It is true that for every dollar we spend on the space program, the U.S. economy receives about $8 of economic benefit. In 2004, the Federal Aviation Administration estimated that NASA's profits from the transportation business alone generated $96 billion. This pales in comparison to NASA's $15.2 billion budget for that year. It shows that space program generates plenty of revenue before calculating debatable economic impacts, such as technology advancement. The budget for NASA is not large to begin with, is not fiscally demanding. Since 2003, the budget for NASA has not exceeded 0.7% of the total U.S. revenue. Space flight programs cost about $7 billion a year. To put that into perspective, at least $10 billion every month is spent on involvement in war overseas today. Though obviously not part of the nation's budget, we spend more than $154 billion on alcohol a year. Well, I don't spend that much, but someone seems to be. Much of the technology and other services that we use today and the business that comes from it is directly a result of developments brought about by space exploration. Man-made satellites have arguably been the largest sources of this. Speaking strictly about communication, satellites have given us many services that we take for granted today, such as satellite radio, television, GPS, and many other things, as well as the technology that allows us to access them. In fact, many technologies that we use and buy today on Earth are a result of endeavors in space, such as home insulation, smoke detectors, LEDs, artificial limbs, digital mammography, and collision avoidance systems in planes, and many others. All of these are bought and sold by private companies and generate revenue. When satellites were first used on Earth, efficiency of aircraft flight paths increased dramatically and saved money and fuel. In 1971, when deployment of satellites was still a bit pricey, Intelsat, a satellite communications provider, still managed to make a yearly profit of 15.8% return on its capital. Indirectly, these are also funds that pay for the space program and that these companies pay taxes according to their profits. The future of space exploration proves to be exponentially more profitable. There are tons of resources found in space that we have trouble finding on Earth in large amounts, or that we spend exorbitant amount of money doing so. Asteroid mining may be one of the most profitable opportunities in space and the solution to this problem. John S. Lewis, a professor of planetary science at the University of Arizona, states, an asteroid with a diameter of 1 kilometer will have a mass of about 2 billion tons. One of these asteroids would contain 3 million tons of nickel, 1.5 million tons of metal cobalt, and 7,500 tons of platinum. The platinum alone would have a value of more than $150 billion. Of course, these numbers would be limited by payload capacity, the shipping costs, and it only applies to certain kinds of asteroids. However, materials found on asteroids can also be used to supply ships already in space with vital resources like radiation shielding without having to ship them back to Earth. Water found on asteroids can also be used to nourish people already out in space at a much cheaper cost than rocketing the water from Earth to the ships when the water sources above the ship aren't enough. Admittedly, these options are at least a few decades ahead of us, and most are not willing to take these steps yet. However, a source we are beginning to tap into now is space-based solar power, or SSP. Because of the Earth's atmosphere, only a percentage of solar radiation actually hits the Earth's surface. However, in space there is no atmosphere, no ozone, no clouds. This allows space-based solar panels to operate at their maximum potential. The power would then be sent back to Earth using microwaves. Unfortunately, the technology to do this is limited at the time, and this power can only be sent about a few kilometers before it starts being inefficient. However, if technology advances, the idea would no longer be far-fetched. Space tourism has become a recent phenomenon that, although expensive today, increasingly becomes more profitable and easier. Commercial suborbital flights have been around since 2004 and simulate the effects of weightlessness found on Earth without actually exiting the Earth's orbit. The Virgin Galactic is one of about a dozen companies that offer suborbital flights. Virgin has pre-sold 200 of their $200,000 seats for their upcoming suborbital flights. Commercial orbital flights have not yet become a business anywhere in the world, but there are a few companies that are developing them. One of these companies, SpaceX, has completed test firing of their rockets for their orbital flights as of March of this year. In conclusion, space exploration programs have a positive impact on the economy, and that goes beyond the cost due to profits generated from research and development of technologies and the use of services provided by satellites and other equipment in space. The future also promises to be even more lucrative as we come closer to a more spacefaring society.
All right, you've got a good quote at the beginning, and you identify the claim that you're making very clearly. You provide some controversy with the fact that the Constellation program was canceled. You don't really preview what the supporting structure is going to be, and during the speech, I didn't think that the supporting structure was very well signposted. Now, at the end of the presentation, after having heard some of those arguments, I think you rescue that a little bit by reminding us about what the main points were, and all of a sudden, it seems to be a little bit more structured. So that would be something that you'd want to get better at the beginning of the presentation. Be sure that you're signposting during the speeches. On the other hand, the evidence is excellent. You've got consistent citation of your authorities. You do a good job providing us with qualifications for the sources that you're citing. There's some comparative data. There are a few inferences that I'm not sure are automatically applicable to government funding of space, for instance, but there is some good data that does apply to those sorts of things. The presentation is pretty good, except that you should get your hands out of your pockets and relax a little bit, but otherwise I think your voice projects really well, and you look at the audience providing us with a little bit of confidence in you as a human being. Thank you.